All right, let's dive into an absolutely incredible geological detective story. We are going on a journey 3,000 kilometers straight down to uncover a secret that connects the very heart of our planet to the roof of the world. Yep, the Himalayas and then massive Tibetan Plateau.
It's a question that sounds like it's straight out of science fiction, right? But the answer is very, very real. Down at the boundary where the Earth's mantle meets the core, there's a mystery of continental proportions. And understanding it is the key to figuring out the immense forces that are still actively building the mountains of Tibet today. So our journey starts deep, deep inside the planet. See, to understand what's happening on the surface, we have to map the depths. And by using the echoes from earthquakes, scientists have found two colossal, really enigmatic structures that are frankly changing how we see our entire world. They're called Large Low-Velocity Provinces, or LLVPs for short. And when I say large, I'm not kidding. These are some of the biggest features on the entire planet. And you know what? Until pretty recently, we didn't even know they were there. Just to give you a sense of scale, these things can tower up to 900 kilometers high, right off the core. To put that in perspective, Mount Everest would be a tiny, tiny foothill next to them. These are massive thermochemical piles, and they influence everything that's flowing in the mantle above them. Now, what's really fascinating here is that these two blobs are not twins. Not at all. Seismic studies show the one under Africa is taller but less dense, which could mean it's less stable. This difference, well, it's a crucial clue in our detective story, hinting that these two giants have very different pasts. So you might be wondering, where do these continent-sized structures even come from? Well, to answer that, we need to zoom out and look at the powerful engine that drives our entire planet, the slow, relentless churn of plate tectonics. The leading theory is that these blobs are basically ancient graveyards. They're these vast piles of old oceanic crust that got pushed or subducted deep into the mantle over hundreds of millions of years. Just think of it like a massive planetary conveyor belt, but in super slow motion. Old, cold oceanic crust sinks, and that drives the flow of the mantle, pushing continents around on the surface. And it's that exact motion, a continent getting pushed, that's going to take us from the bottom of the world right up to the very top. Okay, so let's follow that conveyor belt to probably the most spectacular show on Earth, the collision that created the Himalayas and lifted the entire Tibetan Plateau miles into the sky. We're talking about the monumental impact between the Indian and Eurasian plates. And this isn't just any crash. It is the greatest continent-on-continent collision in our planet's history, and its shockwaves are still shaping the world today. And get this wasn't a one-time thing. It's a slow-motion crash that started 50 million years ago and is still going on. The Indian plate is still pushing north, crumpling the crust, and shoving the Himalayas and the whole Tibetan Plateau higher and higher every single year. So here's the crucial question, right? How do we possibly know what's happening deep beneath the Tibetan Plateau right now? I mean, you can't exactly drill through the Himalayas. So how do you see the geological fingerprints of a crash that's 50 million years old? Well, this is where the detective work gets really clever. Scientists use a technique called geomagnetic induction. It basically uses the Earth's own magnetic field to map out how well the rock below conducts electricity. And a spot with really low resistance is a huge red flag for one thing: liquid, molten rock. And this illustrates exactly what they found. When they scanned the crust deep beneath the Tibetan Plateau, they found it: pockets of extremely low electrical resistance. These are the fingerprints of the collision, patches of partially melted rock, still hot from the sheer force of an impact that started 50 million years ago. Let me just say that again because it's wild. The immense, ongoing pressure from India slamming into Eurasia is still generating enough heat to actively melt rock today, deep beneath Tibet. It's not ancient history. It's a direct, measurable effect of a collision that's happening as we speak. And this just shows you our planet is anything but static. It is a living, breathing, dynamic world. From those ghost continents sitting silently at the edge of the core, all the way up to the still melting rock being squeezed out from under the Tibetan Plateau, Earth's ancient story is still being written, right now, deep beneath our feet.